Get this, Earth has a new moon.
Well, a mini-moon, really.
Okay, mini-moon.
Uh,
But still pretty cool, right? We're diving into all the details about this new little space visitor, 2024 PT5.
yeah.
Where'd it come from? How long is it going to stick around? And why are all the scientists so excited about it?
Yeah, it is pretty exciting. And you're right, these captures probably happen more than we realize, but they're really hard to detect.
So it's like Earth is playing a game of cosmic hide-and-seek with these asteroids.
Exactly.
And we finally spotted one.
Yeah, we got lucky. This little guy, 2024 PT5, was just discovered last month, actually, on September 29th by astronomers at the Complutense University of Madrid.
Wow.
And get this, they made the discovery using a telescope all the way in South Africa.
Talk about international teamwork.
Yeah.
So just how small are we talking here? Is this mini-moon going to be eclipsing the sun anytime soon?
Not a chance. 2024 PT5 is only about 33 feet wide. Think like the length of a school bus.
Okay.
And our moon is over 2,000 miles in diameter.
All right, so no surprise eclipses anytime soon. Got it. But wait, if it's that small, how can scientists even study it? You mentioned telescopes. Is that the only way we can even see it?
You got it. 2024 PT5 is way too dim to be seen with the naked eye or even amateur telescopes. But for scientists, it's a gold mine. It's a chance to study a piece of the Arjuna asteroid belt up close.
Hold on, rewind. The Arjuna asteroid belt. That's different from the main asteroid belt we always hear about.
Right. The main asteroid belt hangs out between Mars and Jupiter, but the Arjuna belt is different. It's a group of asteroids that share Earth's orbit around the sun.
Huh.
So they're kind of like our cosmic neighbors, following a similar path.
So sometimes they get a little too close.
And that's when Earth's gravity snags them, turns them into mini-moons.
So 2024 PT5 is like that neighbor that just keeps popping in for surprise visits.
Uh-huh. Exactly.
Okay, so how long is this visit going to last?
Well, enjoy it while it lasts, because it's a short one.
Mhm.
2024 PT5 is only expected to hang around for 57 days until November 25th, and then it's back to orbiting the sun.
A cosmic drive-by. Okay, so we know it's small, temporary. It came from this Arjuna asteroid belt. But what makes this mini-moon so scientifically important? Why are all the scientists geeking out about this thing?
Well, mini-moons like 2024 PT5 are like little time capsules from the early solar system. By studying their composition, we can learn about what materials were around billions of years ago when the planets were just forming.
So it's like having a little piece of the solar system's baby pictures right here in our cosmic backyard.
You could say that.
But what's it actually made of? I mean, is it just a big hunk of rock, or is there something more interesting going on?
That's what scientists are trying to figure out. They use a technique called spectroscopy to analyze the light reflected from the mini-moon,
Okay.
which can tell us a lot about what it's made of.
Spectroscopy. I think you got to break that down for me. It sounds a little high-tech.
Haha. It is basically by studying the specific wavelengths of light that are absorbed or reflected by an object, scientists can figure out what elements and minerals are present. So it's like taking a cosmic fingerprint of the mini-moon.
Wow, that's incredible. So by analyzing that cosmic fingerprint of 2024 PT5, scientists can figure out what it's made of and even maybe how it formed.
Exactly. And that can tell us a lot about the conditions in the early solar system, how asteroids formed, maybe even shed some light on the origins of planets like Earth.
Wow, my mind is officially blown.
Mm-hmm.
So we have this tiny mini-moon zipping around Earth carrying all these secrets about the early solar system. What's next for 2024 PT5? Are they just going to watch it drift away, or are there plans to try to study it more closely?
Oh, they're definitely going to be making the most of this short visit. They'll be tracking its orbit really carefully, taking those spectroscopic measurements and just trying to learn as much as they can before it says goodbye.
So it's like a 57-day crash course in mini-moon science.
Uh-huh. Pretty much.
But hold on, if we could detect these mini-moons and track them, could we theoretically capture one? I mean, wouldn't that be amazing?
That is a fascinating thought, and it's something that scientists have actually been looking into. Imagine being able to bring a mini-moon into a stable orbit around Earth.
It'd be like having our own personal asteroid to study right here.
Exactly. Think of the possibilities. Detailed analysis of its composition, testing technologies for asteroid mining, even using it as a stepping stone for deeper space exploration.
That would be revolutionary. But for now, we've got 2024 PT5 to keep us company. It's a good reminder that space is full of surprises, even right here in our own cosmic neighborhood.
Absolutely. This mini-moon visit really highlights that our solar system is a dynamic and constantly changing place. And who knows what other wonders are out there just waiting to be discovered.
I, for one, am ready for the next cosmic surprise. But before we get ahead of ourselves, let's delve into some of the other mini-moon discoveries. We'll be right back to explore some of the most notable visitors that have graced our planet's orbit. Stay tuned.
It's kind of mind-boggling to think that as we're going about our daily lives, this tiny asteroid is silently circling our planet.
Right? Makes you realize how much is happening out there in space that we just don't even know about.
Totally. And the fact that 2024 PT5 isn't even visible to the naked eye makes it even more mysterious. It's like this hidden world right here in our cosmic backyard.
Okay, so I have to ask, if we could capture a minimoon, how would we even do that? I mean, it sounds like science fiction.
Ahaha. It would definitely be an engineering challenge.
Yeah.
One idea involves using a spacecraft with a giant net, or even like a harpoon,
Whoa.
to actually snag the minimoon, then use really precise maneuvers to slowly nudge it into a stable orbit around Earth.
So like a cosmic lasso.
Exactly.
That's amazing. But wouldn't it be incredibly difficult to control something like that?
Absolutely. It would require insanely precise calculations and maneuver. I mean, the slightest mistake could send it careening off in the wrong direction.
Yeah, so a risky move, but potentially huge payoff. But before we get too far ahead of ourselves, we were talking about past minimoons. Didn't we have one hanging around for over a year back in 2006?
You're thinking of 2006 RH-120. It orbited Earth for about 18 months. It gave scientists a much longer time to study it. There was even some speculation that it might actually be space junk.
Really?
Yeah, like a remnant from an old rocket launch.
Wow. So a piece of our own trash came back to visit us. That's kind of embarrassing.
Yeah, little ironic. But analysis eventually showed that it was actually an asteroid.
Oh, good. So at least we had one confirmed long-term minimoon visitor. What about other ones? Any other surprises?
Well, there's 2020 CD3, which actually orbited Earth for 3 whole years, from
Wow.
2018 to 2020.
Years.
Yeah, this discovery really cemented the idea that minimoon captures are probably way more common than we initially thought.
So Earth is kind of like a cosmic collector,
Yeah.
gathering up all these little space rocks.
Kind of. What happens to them after they leave Earth's orbit, though? Do they just disappear back into the vastness of space?
Right. Where do they go?
Well, not necessarily. Some might continue to orbit the sun and maybe even encounter Earth again at some point in the future. Others could be influenced by the gravity of other planets and end up on totally different trajectories.
Wow. It's like this constant cosmic dance with these minimoons flitting between planets.
Exactly. The gravitational interactions between planets and these little objects can create some pretty crazy paths.
That's amazing. It makes you wonder what other celestial surprises are out there just waiting to be discovered.
It really does. And, the fact that we're even able to detect these minimoons now speaks volumes about how far our technology has come.
It really does. I mean, it wasn't that long ago that the idea of minimoons was just a theory.
Right. And now we're finding them more and more.
Yeah.
It's really a testament to all the advances in telescopes and our ability to track even these tiny objects in our cosmic neighborhood.
I was just thinking that. It's amazing to think about what we might discover next, especially with these new telescopes coming online like the Vera Rubin Observatory.
Oh, absolutely. The Vera Rubin Observatory is going to revolutionize our understanding of the solar system.
How so?
Well, it has this incredibly wide field of view, and it's super sensitive.
Yep.
It could potentially find hundreds or even thousands of new minimoons.
Thousands.
Yeah.
You serious? So we could be on the verge of a minimoon gold rush.
Uh-huh. It's definitely possible. And, with each new discovery comes a chance to learn more about where we came from, the evolution of our solar system, and just the incredible diversity of objects that are out there.
This is incredible. Can't wait to see what we find next. But for now, let's get back to our current minimoon guest of honor, 2024 PT5.
Okay.
What makes this one unique? What can we learn from it?
That's a great question. Every minimoon is unique in its own way, like a little cosmic snowflake.
Oh, cool.
In the case of 2024 PT5, its significance really lies in its potential to teach us more about the Arjuna asteroid belt.
So how does studying this one tiny minimoon give us insights into this whole asteroid belt?
Well, remember those Arjuna asteroids share Earth's orbit, right? Which makes them more likely to become minimoons.
Makes sense.
So by studying 2024 PT5's composition, we can kind of get an idea of what those asteroids are made of and maybe even figure out how they formed in the first place.
So it's like we're taking a sample from this cosmic neighborhood without actually having to fly all the way out there.
Exactly. And since those Arjuna asteroids are relatively close to Earth, they could be good targets for future asteroid mining missions.
Oh, wow. Now you're talking, what if we could actually capture a minimoon and mine it for resources? I mean, is that even possible?
It's definitely an idea that people are exploring. Even those small minimoons can have valuable resources like water platinum, even rare earth elements.
So instead of sending these expensive missions to the asteroid belt, we just bring the asteroid to us.
Yeah, It's a pretty ambitious idea, and there are definitely some technological hurdles to overcome, but it's not impossible.
It's amazing to think about all the potential of these minimoons, not just for science, but for space exploration, and maybe even using them for resources. Feels like we're at the beginning of a whole new chapter in space exploration, doesn't it?
I think so. The discovery and study of minimoons really shows what we can do in space. And with every new minimoon, we find we're learning more about the universe and pushing the limits of what's possible.
Well said. Who knows what the future holds? Maybe one day we'll have minimoon mining operations right here in Earth's orbit. Or maybe we'll use them as stepping stones to travel even farther into space.
The possibilities are endless, and it all starts with that curiosity, the observation, and that desire to explore what we don't know.
Well, folks, there you have it. Our deep dive into Earth's new Minimoon 2024 PT5.
A tiny visitor with a big story to tell.
It's a good reminder that even right here in our own cosmic neighborhood, there's still so many amazing things to discover. Until next time, keep looking up and never stop exploring the wonders of the universe.